Hello everyone, I'm Pei Zhang from Red Hat. Xiang Chunfu and I will prepare this video together. We will talk about fraud detection using confidential containers on BM TDX with OpenShift AI with ITA and Trustee operator. This demo we will mainly focus on showing using the ITA and Trustee to decrypt an encrypted AI model which runs in confidential containers using TDX. A simple introduction about the fraud detection. Fraud detection is an AI model which monitors the credit card transactions for potential fraudulent activity. It analyzes the data including the geography, distances, the price, and whether the user completes the transactions by using hardware, PIN, or online or offline purchase. By analyzing this data, it will tell users if a credit card transaction fraud or not. So for more information, you can click this workshop for more details. This picture shows the three phases of the OpenShift AI when deploying the fraud detection scenario. The first phase is develop and train the AI model in the Jupyter notebook. The second phase is after the AI model is trained ready, the AI model is uploaded to the storage, to the main I/O storage. And the third phase is download the AI model from the storage and run this model. How about with the confidential containers enabled? The main difference is that the AI model is encrypted in this demo. So after the AI model is developed and trained ready, we encrypted this AI model and upload the encrypted AI model to the storage. So when serving this model, it downloads this encrypted AI model and then decrypts it using the decryption key. So actually, we will mainly talk about how we get this decryption key from the Trustee, Secret, and ITA. I will show the workflow later. After the AI model is decrypted successfully, then we can run this model. Also, in today's demo, we will run the model serving pod inside the confidential containers. Okay. So next slide, let's show the detailed workflow. There are several components and including the keyboard KBS, ITA, AA, CDH, and I will give a simple introduction about them. The Trustee keyboard service is a server that facilitates the remote attestation and secret delivery. The ITA, it verifies the evidence and sends the attestation token. Confidential Data Hub, it facilitates the secure key retrieval for Kata agent and applications. The attestation agent, it's running inside the TE and it connects to the KBS in order to perform the attestation. The attestation agent is responsible for sending the evidence from the TE to prove the trustworthiness of the environment. Yeah, this is the simple introduction about these components. And in our demo, we are deploys OpenShift on the bare metal, on the TDX bare metal, and the model serving pod, which we also call it a fraud predictor pod, is running inside this confidential VM, and there are three containers inside this pod. We will mainly talk about this one, storage initializer, which is a unique container. This container is mainly responsible for downloading the encrypted AI model and decrypted it. So let's say the process. It downloads the encrypted AI model from the main I/O storage, and then it needs to get a decryption key to decrypt this model. So how to get this decryption key? It sends the requests. This key is in the KBS secret, so the container sends the requests through the CDH REST API, and the CDH sends this request to the KBS. However, the KBS will release this key only after it gets the attestation token. So the next step is that the attestation agent, it sends the evidence from the TE to the KBS, and then the KBS sends the attestation request with this evidence to the ITA. The ITA verifies the evidence, and after the verification, it sends the attestation token to the KBS. Now the KBS gets the attestation token, and it will release this key to the CDH. So the container can get the decryption key, and then the AI model can be decrypted, and the model will be served. So these containers will be running to serve the model. So this is the whole workflow. How about without the TDX? Let's say the example with run C. In our demo, the predictor pod will default running with runtime class. So the components are similar, but there is no confidential VM because it's running with the run C runtime class. There's no VM. So let's still say how the storage initializer gets the key. It downloads encrypted AI model, and it needs to get the decryption key. It sends requests to the by the CDH REST API. However, it will fail. This is because the CDH is deployed inside the confidential VM. However, there is no such VM, so the CDH is not accessible. Thus, it fails to get a key, and then the model decryption failed. So this means that the model cannot be served because it cannot get an decrypted AI model. So this picture shows that without the TDX, the model, the encrypted AI model cannot be decrypted successfully because it fails to get the decryption key. Okay. Next, let's switch to the demo part. So let's start from the operator's installation. Because we have shared the mode, we have the fraud detection setup is very similar with the previous demo we did, which is the upstream trustee, but without the ITA. So I will not repeat these steps, but I will just show each part, and I will show what we did in each part to simplify things. Okay, so let's say the operators we installed, including the Red Hat OpenShift AI, OpenShift Sandbox Containers operator, OpenShift Serverless operator, Service Mesh operator, and Trustee operator. After the operator installed, let's open the OpenShift AI page. We have created a data science project called fraud detection. So let's open the fraud detection project. We have already created the S3 compatible storage, the MinIO storage, and we call it my storage. And also we created a workbench called the fraud detection. The workbench is an isolated area where users can develop and train their AI model. The S3, the MinIO storage, the storage is used to upload the AI model. So we can see that this storage is connected to the fraud detection workbench. So this means that we can use this storage in the workbench we created. Okay. After the workbench is created successfully, let's open the Jupyter environment so we can develop and train our data using the Jupyter environment. Yeah, let's open it. We can clone the repo here and open the repo. This this codes in this code we mainly finished the model developing, model training, and saving model locally and encrypt the model. Okay, so let's say the detail steps, including install the Python dependencies, load the CSV data, build the AI model, and train the AI model. Model training is complete, and save the model locally. After the model saving, we can see here we will have a new directory. The model will be saved here locally, and we confirm the model was created successfully, and we test the model, and this is an example running. It shows the AI model works. Okay, this steps shows that the model is encrypted. We are using the fancy method using the key.bin to encrypt the AI model, and so up to now we remove to only leave the encrypted AI model. Yeah, so these are the steps. So with this, with the code in this page, we finished the model training and we get an encrypted AI model locally. Okay, so this page we will upload the AI model to the storage, to save this model to the storage so that you can use it from various locations, including the other notebooks or the model server. The steps including install the packages, verifies upload, and upload and check again. Yes, the models are here, are under the models fraud directory. Okay, so up to now we have trained the model, encrypted the AI model, and also upload the encrypted AI model to the storage. Okay, next step we will serve this model. Let's get back to the OpenShift AI page. Click the models tab. Let's deploy the model. Let's call the model name fraud serving runtime. Let's call it. Let's choose the OpenVINO framework. Let's keep them as default. Model location, let's choose the storage we created, which called my storage. The path is models fraud is and models fraud. Okay, let's deploy this model. It's in the process. Let's switch to the pod. We can see we have this pod is running called fraud predictor. It's init error. Yeah, this error is backed because the fraud detection this is because the default runtime class is with the runC, as we mentioned in the previous slide. With the runC, the storage initializer, it fails to get a decryption key from the CDH, so the model cannot be decrypted successfully. That's why the storage initializer container always fails. Okay, so let's switch it to the CC TDX runtime class name. Yes, we need to do some changes. Thanks Xiangchun for support the efforts. We are able to do the changes easier. We don't need to do these changes in the web console, so we can just simply change it by the command line. This command is change the OpenVINO image server. We replace it with unworkable one. And this command, it disables the istio setcar because we hit segment fault, and we add the runtime class name for the predictor pod. Okay, so let's run these two commands. Yeah, patched successfully. Let's get back to the pod. We can see we have an extra pod which called predictor02. It's in init container is running. During this time, I would I would open the KBS logs, because here we can see if we can get the key from the KBS. Yeah, let's just wait a few seconds. So the container can only get the key if the KBS could get the attestation token from the ITA Trustee authority, from the ITA. Yeah. Let's say the logs. You can see here that the ITA Trustee authority, the ITA, post the attestation request, and the KBS could get the results from the KBS. The results access request passes policy check. So this means that the init container can get the decryption key from the KBS. Okay, so let's get back to the pod part. Let's click this pod and check the logs. Okay, let's say there are 3 containers, and the storage initializer is a init container. Let's check the logs. So this part, it shows that it downloads the encrypted AI model from the storage successfully, and then it retrieves the decryption key from the KBS, and after it gets the decryption key, it decrypted the AI model, so the file was decrypted successfully. So these are the full logs of the storage initializer. It shows that it downloads the encrypted AI model and decrypted the encrypted AI model successfully using the decryption key, which was retrieved from the KBS secret, and after it gets the attestation token from the ITA. Okay, let's get back to the pod part. It's still, yeah, the pod is still pod initializing. This will take a few seconds because the pod is large. We set 22 CPUs and 120 GB memories, because the total size of the container images inside the predictor pod is about 7 GB. It's large, so it will take a bit while. Now it's running, so this means that the model serving pod is running successfully. Now we could able to get the inference endpoint. Yeah, we can do a test via this inference endpoint. Let's copy it and let's open the Jupyter environment. Yeah. You can see that the deploy model name is, we set it as fraud inference endpoint. Let's copy the one we created. Yeah, this one, and we let's run build and submit the REST request. Okay. Data threshold, and it's a fraud. Okay, so these are the examples. The first yeah, sorry, we have showed the data. This is because I have tested this before, but we can just run it again to see if it can still have the results. So this example is a user buys a coffee. The data is like this. The same location as the last transaction, and it's the same median price. So the data is 1. The user is using the PIN, using the chip, and it's an offline transaction. So yeah, let's say, yeah, the model thinks this is not a fraud. Okay, so below is another example. In this example, someone stole the user credit card and is buying something online. The data is very far away from the last transaction. The distance is 100, and it's a similar median price. The data is 1.2, and user is not using chip, not using pin, and it's an it's an online transaction. Yeah, the model thinks this is not a fraud. So these are the we send some request through the REST API. So this shows that the AI model works, and we could get the results from the AI model. We can get the prediction. Okay, so yes, that's all the demos. Thank you for your watching.